Okay. I am doing kind of a sound test here. Making sure we get sound first. Apparently we got sound. Kind of a sound test here. All right, so I'm going to assume that we're going to keep sound. I am going to apologize about all this. I wanted the class to go in person, but I may not have been able to make it happen for both in person and streaming. So I've chosen to do this today. I'll be able to maybe fix it, and we'll try to fix everything for next or this coming Friday. Okay, so word of the day. Let's just use submit. Okay. All right, so let's move on and start working problems in this section, and that's all I'm going to do today. So let me get this set up. So okay, all right, so these are my two items here. So on all of these we're basically going to be summing the forces in the x direction equals 0 because it's a static member, and summing the forces in the y direction because right now I'm doing two dimensionals. So the question is, what forces and how? Okay, so let's take a look at this and say to ourselves, okay, this is supposed to be 550 pounds. So this is 550 pounds. This I'll call the tension in C. This one I'll call the tension in B. And what I'm going to do is just pull this off, and there's the free body diagram right there. Now there's an extra part to it, and that extra part is this, okay? And that is that this is 4 and 3 and 5, and this is 30 degrees. So what I've got to do is I've got to break this into x and y components, and then I have to break this one into x and y components. This one's pretty easy. There is no x component. So I'm going to start with some of the forces in the x direction. What I've got is a value here, which is 4/5 of TC in the positive direction. And I've got a value that runs back this way, that is TB times the cosine of 30, and it's running backwards to the left. Now in the book, usually they'll write a plus sign right there in front of the summation symbol to tell you which direction you're going in. So I got TB cosine 30, and I have no other forces in the x direction. So essentially you have an equation which looks just like this. So there's one equation. Now let's head off and see if we can find the other one, sum of the forces in the y direction, and we'll designate that being positive. And okay, so I've got a component going up here, and that component is 3/5 of TC. I'm using this as the ratio. 3/5 is to this to that. So now I've got a component going north here, and they're both going north. So north being in the positive y, I get TB sine of 30 But then I have this component going directly south. Minus 550 equals to 0. So guess what? I have this as the second equation. Now, this is the way I do things from here on, is I like to put things in matrices, and the reason being will become apparent later, but for right now, I'm going to break these apart and try to put them in a 2 by 2. I have two unknowns, TB and TC. So I'll just list them here. And I've got to have a right-hand side. Now, what's in the left-hand side? Now, here's the key. This box here is going to be that equation. This box right here is going to be that equation. So, excuse me. So what I'm going to do is I'm going to grab them. Now, TB is the first component, goes in here, and TC goes here. So let's do that. TC goes in that column. So all you do is look at the coefficients of TB to go in the first column, and that's these two, and it's a minus cosine of 30. Now look at TC, the components here go right there, and that's 4/5. What's on the right hand side? It's nothing but a 0. So if I went through the process of multiplying this out times this and that would give me the first equation. Look at this second equation. Now I'm looking down the first thing right here, looking for the coefficients of TB in this equation, and that's sine of 30. Now I'm looking right here, the coefficients of TC, that's this, 3/5. Now I'm looking at the right hand side. Now I can take this and move it to the right hand side, and it becomes a positive 550. So now let's take a look at this equation inside of octave. Okay, now this was left over from dynamics, so I think I'm going to clear it, and I'm going to clear the screen. Oh, caps lock. Clear it. Oh, caps lock again. Okay, clear it. Clear the screen. So I'm going to call that matrix a K, for lack of a better word. And I'm going to say minus cosine degree of 30. That goes in the first one, and then 4/5. And then the next row is sine degree of 30. And then 3/5. And that's it. And so there's your matrix. Now my right hand side, I'm just going to call RHS. It's going to be 0, and it's going to be 50. And then I'm going to do the inverse of K times right hand side. Okay, now out of that, so the solution, 478, okay, 478.46, 517.95. So this is the solution out of here. And so all I do is copy this down and say TB and TC equals to that. Now, so those are the two answers. Now let's just double check, because I believe, okay, F3.1, I believe I have the statics thing here. Okay, that is F3.1. Okay, so I've got to be mindful that I go all the way back, I think, to the Okay. 478 and 518. Okay, let's see. 478 and 518. So let's move on now, and we'll just do another one. So here's a different one. Now this one's slightly different, has a little bit of a complexity, but it's not that bad. If the mass of the cylinder is 40, determine the mass of the cylinder A in order to hold the assembly in the position it's shown. So if it's 40, then its weight is 9.81 times 40. Let's see, let me check something over here. Everything is doing okay. Let's see. That is not where I wanted to go. That is where I want to go. $392.40. Okay, so that's the weight in newtons. So what that means is this. I drew the free body diagram. What I would draw is this. I would draw that. And I would draw that. Now what I will do is I will go in and select that, move it to the side, and since this is the weight here, that will be the tension in this wire if this pulley has no friction. So that's just 392.4. Now all I've got to do is sum the forces in the y direction equal to 0, and I'll make up be positive. And what I'll do is weight of A, I'll say minus the weight of A is plus, because this component so it has components going this way and going that way. This is 392.4 times the sine of 30. So it's 392, or I could do this. I could go back to that representation. 40 times G, which is what this is. The weight is equal to the mass times the gravity, but I'm going to rewrite the G is just a G. So I could put in 392 right here, which is what that is, or I could put in 40 times G. You'll see why in a second I do that. And then I multiply times the sine of 30. So if I want to move this to the other side, then the weight of A, which guess what? That's the same, that's the mass of A times the same G that's effectively right there, is equal to 40 G times the sine of 30. I can cancel my G's, and so now my mass of A should be 40 times sine of 30. Gotta make sure, I just want to make sure. 20. So according to this, the mass of A should be 20. Now again, I do have a problem number 35. Okay, go back over here. 3, 4, 3, 5. Okay, so there's our 20. So let's just roll on. Okay, now this one's a little bit different. This one had a picture, and this is out of the book. I just copied these before I started. This one's out of the book, and it has 2 questions on the same problem. The first one says, if a 30 kilogram pipe is supported at A by a system of 5 chords, 1, 2, 3, 4, 5. Determine the force in each chord for equilibrium to occur. Okay. So again, this thing is, here, let me zoom in. So now I've got a set of chords that do this, that do this, and that do this. And I'll need that 60 degrees with me. And then I got another set of chords that do this, and do this. And this, I'll need that, the 4, 3, and 5. Now, what I should do, I'm going to go ahead and do this. I'm going to designate 1 as being a little bit different. Okay, so the green one, I'll take it on out. Okay, wait a minute. It looks like I need to somehow copy it. Or here we go. So here, I'm going to drag it to the side. And then I'm going to do the other one. And I'm going to drag it so they kind of point at each other along this line, but they're kind of further apart. So if you look at it, I'll try this. This is what I mean. Okay, so they kind of moved further apart. So this is tension AB. Okay, so what I mean is the tension in rope AB, the tension in rope BD, the tension in rope BC, and the tension in rope AE. And then this one is just, what did it say, 30 kilograms times 9.81 is equal to the weight. So let me just get that number real quick. Okay, 30 times 9.81, 294.3. Okay, so that is 294.3. That is the weight that's being pulled down here. So that's 294.3 newtons, which is equal to 30 kilograms times 9.81 meters per second squared. So now I need to take these values and list them on the 2 free body diagrams. I've got 2 of them. I got the green one, I got the blue one. So I have enough room, I think, to sort of split the problem like so. So maybe I'll do it more like this. So the blue one, I'll work down here, and the green one, I'll work up here. So the green one, I'll work here. The blue one, I'll work here. So I think I want to start it on a blue one. And if it's a blue one, let's make it blue. So the other one is I have tension AE. Okay, so let's just work on this one. So again, sum of the forces in the X equals 0, and I'll make that be positive. And so what I get is I get that force going directly to the right, TAE. This force has no X component. This, however, does have an X component. If you look at TAB, and you're looking at the X component there, and that's 60 degrees, then that's nothing more than cosine of 60 degrees times TAB. So, and it's going backwards to the left, opposite of that. It's TAB, cosine of 60, and that's it. There's nothing more. There's only this force, this one, and only these two have an X component. So from that, I'll say I've got the first equation. Now, I'll go ahead and get rid of this, and I'll do sum of the forces in the y. I'll make that be positive. So I'll just go ahead and take that and put in here. It's 294.3. Now, this one has no y component, but this one does. And again, you have the TAB. This time, you're only looking for this component, which is TAB 60, 60, 60. That's 60 degrees. Times the sine of 60 degrees. So, and that's going upwards. TAB sine of 60. And that's it. Now, here you could, if you felt so inclined, and I'm going to do it, but this is not even necessary, and I'll show you why. If you wanted to create this as two equations, you could. And we're just going to do it for practice sakes. Okay, so I take the first equation, I'll put here. I'll take this equation and put right here. I'll take the coefficient of TAB, and that would be minus cosine of 60. I'll take the coefficient of TAE, and that's just a 1. Now, there's nothing on the right-hand side. And so now I'll take the coefficient of TAB in the second equation, sine of 60. And then I'll take the coefficient of the non-existent TAE, and then I'll take the right-hand side, take this and move it to the right-hand side, and you get 294.3. But what you see on the bottom equation is that I have a 0 right there. So it's very easy to take that bottom equation and say TAB is equal to 294.3 divided by sine of 60, which you may have seen this already and recognize you didn't need to create this, but we're just doing it here for practice. So 294 divided by the sine of degree, and I believe it was 60, but I better check back. Yeah, 339.83. Now I can take that TAB, put it in here, and solve for TAE. So from the first equation, okay, now you have to realize this came from the second equation. From the first equation, TAE is equal to TAB times the cosine of 60. I got that from right here. And all I have to do is insert that. And I can take that number and times cosine degree of 60, not 600, 169.9 91. Okay, so here's the deal, okay? I have these two numbers, and let me use the blue to kind of highlight these two. And now let's look at our drawing for a second, and we'll realize something interesting, okay? And that is, on the upper drawing, when we're back in here, this is TAB. These are the same tensions. So from working this problem, I just copy it back over here. This one I now recognize as TBD, and this one as TBC. Now I can take off if I want to go ahead and copy this. Okay, 339.83. So if I run in here and say this is 339.83. Now, because I know that from the previous problem, I can do the sum of the forces in the X and Y here. So sum of the forces in the X will make the right be positive. Okay, now this one I have a component from every single one. So I'll start with the TAB. If you look at it, okay, now I've got to figure out how to draw this, and I'll draw it up here. So here's your 339.83. And as it turns out, this is your 60-degree mark. And back at the drawing, if you look at it, here, now that I have this, and I know these, what I'm calling it, if I draw this line and compare this 60 degrees to that, now I can look up here and say, okay, this vector goes down and it drops with that, and that's what I'm looking at. So the X component there is 339.83 times cosine of 60 going to the right. That's that component going to the right. Then I've got, let's take a look at, well, yeah, let's take a look at the TBD next. And what you get there, and I hope I copied it down right. Yeah, I'm looking at this, comparing it to that. It is going to the right as well, plus, that's why it's a plus, 4/5 of TBD. That is taking 4/5 of the TBD right here. And that's the component here minus the TBC. And that just sets me at 0. Now, summing the forces in the Y direction, making this positive, equaling to 0, I get a Y component here, and I get a Y component here. I do not get a Y component out of this. So, I'll go ahead and do this one first, and it is 3/5 of TBD minus, because that's pointing down, oh, well, I know the number, 339.83 times, and now you're looking for this component, which is the sine of 60, and that's it. So again, you can build the matrix if you wanna, but you can look right here and recognize that I can extract the TBD straight out of there as being 339.83 times the sine of 60 times 5 divided by 3. Okay. Okay, so, all right, here's what I'll do. Got 339.83. I'll just 339.83 times the sine degree of 60 times 5 divided by 3. 490, about 490 and some change. So we'll hold on to that for a second. Let me check this thing over here real quick.
Denied that you are.
Okay. Everything seems to be going okay. All right, so let's run back over here. So now I can take, let's see, I'll go ahead and highlight this to that, and then I'll go back to my green, and I'll take that 490 and stick it in here, pull this equation out, and say TBC is equal to, moving TBC to the other side, we get 339.83 cosine of 60. That came from right here. And then I have to add 4/5 from here, which is that. Put it in here. So 490.5, because that is TBD. And so TBC, which will be a mess. And so I'm going to have to just sit there, and 339.83 times cosine degree of 60 plus 4 divided by 5 times 490.5, which I'm not sure that half meant anything. 562.32. So there's this one. So if I were to list them all out, let's see if I can list them all out. Now he said I have 5 cables. That's right. Yeah, you have 5 cables. This is true. However, one of them was just straight up. It's 294. That's the tension in this cable right here. So I'm not sure that he would list those in the back of the book. I don't know. So what I'm going to do is TAB is equal to 339.83. TAE is equal to 169.91. TBC is equal to 562.32. And TBD is equal to 490.5. Now, with all that, let me see if I can run back here. I guess I need to know the problem number. 326. Okay. Unfortunately, that is, well, wait, that's preliminary problems. Okay. Okay, this is going to be, I'll tell you the way I'll do it. I think it was 326. I don't remember. Okay, so I'm just going to copy that over to here because I can't keep up with this. I'll put it right there. Okay, and what I'll do is, since its writing is kind of smaller compared to mine, I'll do that. Now let's just go through these like real quick, kind of. TAE, there's that one. TAB, you can see he kind of integerized things. He dropped the component. TBC, and then TDB, and he did include this. THA, which is this string 294, and that's what he got right here. So there's his 294, and I didn't even write that one down because I didn't think he was going to do that one. But he did state that it was to be the case. Now, let's do something interesting, and that is we finished this one, right? So now let's look at the bottom. Each cord can sustain a maximum of 500. Determine the largest mass that can be supported. Now let's take a look. We are, in the book, I'm assuming we would probably work that one first, and then we would work this one. That being the case, it can only have 500. So if we look at this, we realize the one that's the highest is right here. And it's over 500. So, and our mass happens to be 30 kilograms on this last one. So let's think about this. Okay, so if I ratioed that 500 over 509, I'm sorry, 562, the 562 right here, that ratio would be approximately, wrong place, 562, 0.889, about 0.889. So here's the thing. What created the 562 was 30 kilograms. So I don't want to go up, because if I go up to a higher, like 31 or 32 kilograms, the tension is going to get higher. So what I need is I need to drop it. And so lo and behold, what happens is these are linear problems. So you take that and you multiply it times the 30 kilograms, and you will get 26.69 kilograms will create that. Now, yes, none of the other lines are at the 500, so the most difficult one is BC. BC. This one is going to be the one under the highest stress. So let's see if that is the case. 26. Now, of course, what he may show up in the back of the book is 27, or he might show up with 26. I don't really know. Well, 26.7. Yeah, so 26.7. All right, let's head off to another one. I don't think I can finish all of these, but let's just keep going, and I will have to truncate because I got to move into the next course. Wait a minute, did I do? Yeah, I did the static square today. Okay, so I'll do the same thing. I'll just go in, draw my vectors. I'll go ahead and put this in here, 30. This one I'll call tension, DE. This one I'll call tension, DC. Now, he says that's a kilogram length, but I'm just going to put the weight right there. And then this one is the same tension as that, DC. So these two, same tension. This one, tension BC, and I'll just draw this down and say 45 degrees. And then this one is a tension AC, and I'm going to put this up here and say a 4, 3, and a 5. Now what I'm going to do, did this before a minute ago, make that one blue, copy it, but I've got to move over it with the mouse, and then I can copy it out of there. And then what I'll do is I'll go in with this one, and I'll drop it down to about right here. Now, technically, I would need to line them up like this, but this time, since I've labeled them, and since these two, this one and this one, have no angles, I'm going to just go with it like this. So splitting them apart, I'll take off on the lower one first, and just to give myself some extra room, I'll move it down a little bit. So he says it's a 20 kilogram lamp. Okay, so the weight is equal to 20 times 9.81. And so now all I need to do is sum the forces, and I'm going to start with a y here because you'll find something interesting here. So the y, I've got this moving, this force going in the opposite direction of the positive, makes it negative. And then I get this one having a component going up, which is the same as over here, which is T, D, E, the tension of the rope there, times the sine of 30. That was 30, wasn't it? Yeah, that was 30. Now I could stop right now and solve for this, or I could go on and then I'll go through the equation. So I think I'm going to go on. Okay, now I'm summing forces in the x. Now what's funny is I only have an x out of this one and only an x out of that one. So since the one on the left is by itself and it has no angles, I'm going to put it first. And then I'm going to take this one, and what I get is TDE cosine of 30, and that's it. So what I've got is two equations now. I made some space between these two for a good reason, and that is because now I can take this one and say TDE is equal to, move this to the other side, becomes positive 29.81 divided by sine of 30. Wrong one. Twenty times 9.81 divided by sine degree 30. 392.4, I think. Yeah. Now I could take this, put it into here, and solve for this equation. So I get TDC is equal to TDE, which happens to be, well, I'll go ahead and write this down. Cosine of 30, which is nothing more than 392.4 times cosine 30 times cosine degree 30 is 339.83. Let's see. So what I'll do is I'll say this one goes together with this one. This one goes together with that one. That way I can color code. I can use these to copy up here. Now, TDC is 339. Okay, now you have to realize this tension is the same as that tension. So this means that this value is equal to 339.83. Now if I head off here, now the reason that's the case is because the tension is the same in this rope all the way along. Now I'm stuck in that I really can't work my way out of this one with a single equation. So let's do sum of the forces in the x, make it go to the right. So I get my 339.8. Was that a 0.8 or 0.83? 339.83. Not that that 0.03 means anything. And now, I've done a strange job here, so I'm going to look at the component going this way, which is going in the minus direction, and it's 3/5 of TAC. The reason that is if you have a vector that goes like this, 3/5 of it go here, and 4/5 go here. In other words, you had a vector that was like this, then this would be a certain number, this one would be 3/5 of that number, and this one would be 4/5 of that number. Just so happens the number was 339. No, in this case it's TAC. It's just TAC. So it's 3/5. 3/5 going in the X. Now, I love 45 degrees because cosine of 45 is the same as sine of 45, and you can check it on your calculator, but it's 1 over square root of 2. And so I just basically immediately go into that and immediately go into square root of 1 over square root of 2. And so I took TBC, this value, and 1 over square root of 2 there. And that's it. I got my forces, all my forces there, and I'm just kind of sitting there. Now I'm going to do the sum of the forces in the y, and of course it's equal to 0. I should have put the 0 here back over here, but it's too late now. Sum of the forces of the y there, I get 4/5 because it's positive. This is going up. 4/5 of TAC, and then I get a minus TBC. This one's going down, square root of 2, and this one has no y component. So if you look at this, now you're going to have to, since you have TAC and TBC in both equations, you're going to have to list these out. So what I'll do, TAC, TBC, and I'll list this equation first and then this equation second. And so I'm looking for TAC component right here, and that is minus 3/5. I'm looking for TBC component, and that is minus 1 over square root of 2. I take this, move it to the other side, it becomes minus 339.83, and I need to list this, TAC, TBC, and the bottom equation. I'm looking for the coefficient of TAC to go in that. That's 4/5. Looking for the coefficient of the TBC to go right there. Minus 1 over square root of 2. And the right hand side is just 0. And so I'll head up into MATLAB. Uh-oh, I don't know what that means. I'll head up into MATLAB, Octave, whatever you want to call it. And I want to build a new K matrix. K is equal to minus 3/5, and then minus 1 divided by the square root of 2. Next row is 4/5, and then minus 1 divided by square root of 2. That's your matrix. My right hand side is going to be minus 339.83, and then the next row is going to have nothing. And then what I want to do is invert K and multiply it times the right hand side, and I get TAC, okay, a 242.74 and 272.62. So this would be TAC because it's in that first row, and TBC in the second row. So these are the two numbers here. Let's go to the back of the book and verify. This is 329. 29. Okay. Now I'm going to have to do the same thing here. I don't have the okay, 329. Okay, so let's go back over here. I'll just drop it right there. But I'll also pick it up and try to move it up. Let's see. It looks like I'm a little bit off, but okay, he called his something different. Okay, TBC C. Okay. So there's 270 T A C. Okay, here's an A and here's a C. 243. So I got 242. T D E 392, which he has that. And then C D is 340. So I think we're pretty much close enough. So, all right. So sorry for having to do it this way. I guess we're done.